How do two spacecraft connect while moving in space? What is space docking, which ISRO did? Well, here we will talk about these things and see why this is being said. Friends, today's video is going to be much more interesting and informative. That's why you will definitely share this video as much as possible and reach many people, so that more and more people will know about it. Apart from this, you are also requested to watch the video from beginning to end. ISRO launched the Spadex mission, under which two spacecraft were deployed from the PSLV-C-60 rocket at 470 kilometers above the Earth. Both spacecraft were traveling at a speed of 28,800 kilometers each. The Indian Space Research Organization, ISRO, has created history by becoming the fourth country in the world to successfully interconnect two spacecraft into space, becoming the fourth country in the world to do so after the US, Russia and China. Now the question is, what is this space docking? How is it carried out? What does ISRO want to achieve from space docking and undocking? Let's find out. The mission was launched on 30th December. ISRO launched the Space Docking Experiment, Spadex, mission on 30th December 2024, under which two spacecraft were deployed from the PSLV-C-60 rocket at 470 kilometers above the Earth. Both these rockets were traveling in space at a speed of 28,800 kilometers per hour. Now ISRO has succeeded in connecting these two spacecraft. Power will be transferred, later undocking will be done. Two vehicles are added to space. Space docking means connecting to spacecraft in space. On 30th December, ISRO launched two spacecraft, Spadex A and Spadex B, into space. The two spacecraft, which weighed about 220 kilograms, were gradually reduced to speed, after which they were joined. This technique is called space docking. After this, there will be undocking. That is, the two spacecraft will separate and start their operations. How were the two spacecraft combined? Under the Spadex mission, two such spacecraft were to be interconnected, which were traveling at 10 times the speed of the bullet, i.e. 28,800 kilometers per hour. In January, the speed of both spacecraft was gradually reduced to 3 meters away, but later they were taken to a safe distance again. Now both spacecraft have been successfully docked. What is ISRO trying to achieve? Space docking technology is very important to build its space station in space. ISRO's goal is to build its own space station in space. Apart from this, the success of Chandrayaan-4 and Gaganyaan mission will also depend to a large extent on space docking technology. The bar will be sent to space. The process of connecting to spacecraft in space is called space docking. It is a complex technical process in which two independently moving spacecraft, such as an orbital module and the other a module or station already in space, are interconnected in space. What is space docking? Space docking means connecting one spacecraft with another spacecraft in such a way that they can serve as a single unit for mechanical, electrical, and data transfer. It requires a lot of precision and coordination to accomplish this, as there is no friction in space and things are moving very quickly in microgravity. How is space docking done? The following steps are followed for space docking. Orbital matching. Before docking, the orbit and velocity of both spacecraft are aligned so that they can move together in the same direction. Rendezvous. A spacecraft, called an active craft, is gradually brought closer to another spacecraft, passive craft. It is done with great care and control so that there is no conflict. Alignment and approach. The docking ports of both spacecraft are aligned in a straight line. This is done with utmost precision so that the two spacecraft can connect properly. Soft docking. After the initial contact, a soft docking occurs in which the two spacecraft are only lightly joined. Hard docking. After soft docking, the spacecraft's docking systems are locked and they are permanently attached. After this, the exchange of data and energy can begin. Importance of space docking. Human space flights. Space docking is used to connect spacecraft during manned missions in space, such as sending astronauts to the International Space Station, ISS. Supply and refueling. Spacecraft in space can be supplied or fueled through docking. Scientific research. Through space docking, larger and more capable space stations can be created by connecting two modules. Long-term missions. For deep space missions, docking is necessary so that the modules involved in the mission can be interconnected. ISRO's Space Docking Mission. ISRO, Indian Space Research Organization, has recently successfully demonstrated space docking technology. This is a major achievement for India as this technology is essential for future manned space missions, Gaganyaan, and efforts to build space stations. Challenges: accuracy required. The orbital motion and position have to be controlled accurately down to the micrometer level. Risk of collision. If there is a mistake in the docking process, the spacecraft may suffer. Communication and control. Precise communication and control from Earth is required during the mission. This success of ISRO will lead India to greater advancement in the field of space science, and it will form the basis for future deep space missions. Let me share more information related to space docking in detail, so that you can get a better idea of its importance, technology, and historical context. Historical significance of space docking. Space docking technology is considered a milestone in the success of space missions. It started in the 1960s when the space powers, US and Soviet Union, attempted to touch new heights in space exploration. First space docking. In 1966, the first successful space docking between Gemini 8 and an Agena target vehicle took place during NASA's Gemini program. It was carried out by Neil Armstrong and David Scott. Contribution of the Soviet Union. The Soviet Union successfully carried out the first manned space docking between Soyuz 4 and Soyuz 5 in 1969. This was another important step in the history of space missions. Space docking and India. The Indian Space Research Organization, ISRO, has also made great strides in adopting and developing the technology of space docking. Recent developments. ISRO successfully tested a spacecraft docking system, which is extremely important for India's future space missions. It will lay the groundwork for India's Gaganyaan mission and the construction of the orbital station. Future plans. Gaganyaan mission, ISRO's first manned space mission, in which astronauts will be sent to the Earth's low Earth orbit. Docking technology will be extremely important for this mission. Indian Space Station. By 2030, ISRO is working on a plan to build an indigenous space station, where docking technology will play a key role. Refueling system. In the future, space docking systems will be used for refueling and long-duration missions in space. Main technologies used in space docking. Automated Docking System, AMS. In this, the spacecraft controls the entire process itself. With the help of sensors, cameras, and navigation systems, it carries out docking. Example, cargo spacecraft sent to the International Space Station, ISS. Manual Docking System. In this, astronauts themselves do docking by controlling the spacecraft. Example, manual docking technology was used during the Apollo missions. Hybrid Docking System, RCS, is a combination of both technologies, in which the first auto-docking process starts and human control can be taken if needed. Key benefits of space docking. Construction of the space station. The construction and expansion of the International Space Station, ISS, would have been impossible without docking technology. It is a platform where scientists from different countries do research together. Long-term missions. Modules can be added and supplied from space docking in deep space missions, such as missions to the Moon, Mars or other planets. Rescue in case of emergency. If there is a technical problem in a spacecraft, the rescue module can be sent from docking. Challenges in space docking. Lack of gravity. Microgravity makes it very difficult to stabilize and connect spacecraft. Extreme accuracy demands the slightest difference in the speed and position of the spacecraft can lead to failure in docking. It has to be controlled with an accuracy of millimeters and microseconds. If the spacecraft is too far from Earth, such as the Mars mission, signals may be delayed, affecting the docking process. Importance of achievement in Indian context. Technological self-reliance. Mastery in space docking will make India self-reliant in space missions. Global competitiveness, this technology puts India at par with the US, Russia, China and Europe. New opportunities, this technology can make India a big player in commercial space services, such as private space missions and cargo delivery. The way to the future. With this achievement of ISRO, India is now set to play a leading role globally in manned space flights, construction of space stations, and long-term space missions. Space docking technology will not only accelerate India's scientific development, but will also open the doors for international collaborations like with NASA, ESA, and Roscosmos. If you want, I can dive more in-depth on any specific aspect, such as ISS, Gaganyaan, or spacecraft technology, smiling face with smiling eyes. To understand space docking and the important aspects associated with it in detail, let's discuss its various aspects in depth. Contribution of the International Space Station, ISS, and space docking. The International Space Station, ISS, is one of humanity's greatest engineering achievements in space. It operates in collaboration with 5 international space agencies: NASA, Roscosmos, ESA, JAXA, CSA. ISS and space docking. The construction of the ISS has been done in a modular manner. In this, various parts, modules, were connected with space docking technology. Example: the docking process took place several times to connect American modules, Russian modules, Japanese lab modules, etc. Cargo spacecraft, such as SpaceX, S-Dragon, Russia's Progress and Japan's HTV, regularly sent cargo and equipment to the ISS. Manned spacecraft, such as Soyuz and Crew Dragon, dock to and from the ISS to transport astronauts. Role of research and docking on ISS. Biology, the study of the effects on the human body in microgravity. Physics, development of new materials and technologies. Earth monitoring, the study of climate change and the environment. Without space docking, a project like the ISS would not have been possible. Gaganyaan mission and India's preparation. Gaganyaan, ISRO's first manned space mission, is expected to be launched in 2025. The objective of this mission is to send Indian astronauts, crew of Gaganyaan, 400 km up to Earth's orbit and bring them back safely. Role of space docking in Gaganyaan. For long-term missions, the Gaganyaan spacecraft will need docking technology in space if it is to be used in future long-duration missions, such as a space station or other modules. Refueling and supply, docking will make it possible to supply fuel and goods for long-duration missions. Crew rescue mission, if there is a technical problem in Gaganyaan, an emergency rescue module can be sent. Stages of Gaganyaan. Unmanned mission, 2024 testing of processes by sending robotic modules, Vyomitra. Manned mission, 2025 sending 3 Indian astronauts. Space docking capability, plans to connect with other modules or space stations in the future. Space docking and deep space missions. Mars and Moon missions. Use of docking, for deep space missions like the Moon or Mars, it is imperative to link the spacecraft together. Example: NASA Artemis program, building the Lunar Gateway Station to the Moon. Mars mission, need for docking for modules and refueling in space. Benefits of space docking. Fuel saving, they can be docked by sending individual modules into space. This is entirely fuel efficient compared to sending a large spacecraft. Increased flexibility, modules can be added or separated at any time from space docking. Multi-mission support, the modules of the space station can be shared with other missions. The key system of space docking technology. Design of the docking system. Probe and drogue system, in this, a probe, extended part, connects to a drogue. This system is common in Russian spacecraft. Berthing, in this, spacecraft are gradually added using robotic arms. Soft capture system, use of soft magnetic lock. Techniques of precision navigation. GPS, to determine the position and speed of the spacecraft. LiDAR, laser-based ranging and object detection. Star tracker, navigation by looking at the position of the stars. Communication systems. high-speed communication link for real-time data sharing between spacecraft. Challenges of space docking. Speed difference. Spacecraft rotate at a speed of 28,000 km per hour. To connect them, position and speed have to be accurately matched. Complex mechanism. The docking system is made lightweight, durable and highly accurate. Communication delays. In long-range missions, such as on Mars, communication between the Earth and the spacecraft can be delayed by up to 20 minutes. The contribution of AI and automation to space docking. AI-based navigation. Modern spacecraft use automated docking systems, which make docking precise using sensors and AI algorithms. Example, SpaceX's Crew Dragon performs fully automated docking on the space station. Robotics. Robotic arms, such as Canadarm2, are used for docking and moving modules on the space station. Planning for India's future space docking missions. Indian Space Station, 2030. ISRO plans to launch its own space station by 2030. It will make major use of docking technology. Steps after Chandrayaan-3. India may work on docking the orbiter and lander in the Moon's orbit in the future. Mangalyaan-2 and Venus mission, Venus. Space docking and refueling techniques will be developed for long missions in deep space. Space docking is the backbone of modern space exploration. By taking a step in this direction, ISRO has proved that India is ready for next-generation technologies in space missions.